All right, limit the domains of the following functions in order to find their inverses. Then graph both functions with its limited domain and the inverse. Find the rule for the inverse. So if we just sketch, here we are, f of x equals x squared, and we're probably getting pretty familiar that this one does not have an inverse. Here's our parabola, and it does not pass the horizontal line test. It goes through 2 points, and so really what we're going to have to limit here is it can only have one side or the other, and we'll go with the positive side just because it's going to be a bit easier as we first are learning this. But we're going to limit the domain so that it will pass that horizontal line test, so that we will have a function and that they will have an inverse. So let's define the domain as being the x values only on that positive side. And so x is going to be greater than or equal to 0, and then looking again at our graph, or that was the origin, our y values, our range, is also going to be y is greater than or equal to 0. Okay, so we've limited the domain here a little bit so that it doesn't have those negative x values. So now let's go ahead and find our inverse. So y equals x squared. That means x equals y squared, and y is going to be equal to plus or minus the square root of x. However, we've already defined our domain as only being those positive x values, so we don't need our negative, the negative version of the square root of x here. So let's rewrite that. Yeah, so we're not gonna need this here. So then the domain of, and remember this is f inverse of x. So f inverse of x is equal to just the square root of x, with the domain here being that x is greater than or equal to 0, and the range is also greater than, or y equals greater than or equal to 0. So let's go ahead and graph these. And our first one is, again, just that positive side of the parabola, just where the x values are greater than or equal to 0. The inverse, and it's going to go over the line of y equals x. The inverse will look like this right here. Oops, that can be a solid line. Or again, we've limited out the y values because we're saying it couldn't include, and it doesn't include negative square root. So no values down below. All right, and the second one here, we've got g of x is 9 minus x squared, and so our domain, if we were to think of this is a parabola that's opening downward, going through, it's got a vertex at 0, 9, and it's opening downward, and same type of problem here. We will not pass the horizontal line test, so let's get rid of the, let's limit the domain so that we only have the positive side. So the domain here is going to be that x is greater than or equal to 0. And now our range, let's see by the graph here, pretty easy. The biggest number we're going to get is 9, and then it heads towards negative infinity. So y is less than or equal to 9. All right. Now as we find our inverse, again, swap your x and y values. So we'll have y equals 9 minus x squared, which is, if we're finding the inverse, x equals 9 minus y squared. I want to get y by itself, so we will, probably the easiest way is add y squared to both sides, subtract x. So y squared equals negative x plus 9. From here, we're going to take the square root of both sides, and we'll get y y equals the square root of, or plus or minus the square root of negative x plus 9. And as we continue on, we don't need that negative portion here. And all right, again, we don't need that negative portion because it's we've already defined our domain or range back up here as being, our range up here as being less than or equal to 9, and so let's finish on up our domain here. What are the x values that we can have? Well, the biggest that x could be would be 9, because if it was 9 here and make that negative, we'd have negative 9 plus 9, which would be 0. But every value needs to be less than that from there on out. So x is less than or equal to 9, which should make a lot of sense because that was our range before. So that's really going to be our input now into our inverse. And so maybe I should write this back as f inverse of x. And so our range is from our original function is our domain on our new function. And then likewise, our range here, and there's no way for me to get any, this is y, remember there's no way to give me negative y values, so y is greater than or equal to 0. And let's sketch that. So our original function in blue, f of x, let's say that's 0, 9, and we're opening downward. All right, reflect that over y equals x, and we get out. Now it's at 9, 0, and is opening back the other way. All right, hope that helps.